So good to see everyone here.
Sorry, do you want
Oh. Yes. For anyone who's been to our previous serverless comps, it's very clear, I think it's clear to everybody that I no longer do the design for serverless comp in Microsoft Paint. So it's awesome. Wow, we've got a designer now. I'm very pumped. So in this talk, I'm going to take you through the journey over the last 2 years that we've been through, building one of the world's first entirely serverless web platforms at scale. So I'm going to take you on the journey of kind of working on leading edge, like really leading edge cloud technologies, running a serverless site before anyone was even using the word serverless, and before you could even call Lambda from the web. And this story, the point of this is to show you some common problems that you might come up against when you start building serverless systems and serverless web platforms, and how we overcame them. And I also think it's a really interesting story to see how far the serverless community and ecosystem and tooling has come in the last couple of years. And this is exactly why we started running the conference, to bring the community together and share these ideas and experiences. So very briefly about me, I'm Sam. I'm one of the founders of Cloud Guru. And if you haven't heard of us, we're an online learning platform and we train engineers in cloud. And we've built our platform serverless. In fact, we're a completely serverless company. The only operating systems that we manage are the ones running on our dev laptops, which I think is pretty cool. And being serverless conf, I feel like I need to prove it to you. So I took a screenshot of our EC2 dashboard yesterday. There it is. Woo! Awesome. We had a developer start, where is he? Dale. When he first started, he spun up a Jenkins server and he got slapped. And he deleted it. So, interesting fact about me, prior to Cloud Guru, I worked for Microsoft in Seattle and in Norway and a few other places. I was a developer on Windows Vista and Windows 7. And I worked in the core file systems group of Microsoft. And my main focus was the disk defragmenter. So I wrote defrag for Windows 7. I got to rewrite it from 0 lines of code, which was really, really fun. And I usually get very mixed reactions when I tell people that I wrote defrag. So I'm definitely a convert to serverless. I actually spent a significant portion of my career building server software and Windows Server. So just under 2 years ago, we started on this journey, and we had this mission of let's change the way that people learn cloud computing. So my business partner and my brother, Ryan Kroonenburg, who's here somewhere today, put some courses on udemy.com teaching people about AWS, and they started getting a lot of traction. So Ryan and I were having a chat one day, and we thought, well, why don't we try to build the place to learn cloud computing online? A massive online community, bring passionate IT professionals together on a journey together to learn cloud. And since launching, we've taught AWS to over 200,000 engineers now in 140 countries in 18 months since we launched the platform. So it's been a pretty crazy journey for us, and we also started a conference at the same time. And I think there's no way to validate this, but I would say we now operate one of the largest and oldest entirely serverless web platforms in the world. So I've got to start this talk with what is serverless, because like John said earlier, I think it's actually still important to try and define this because it can be a reasonably vague term. And this is my talk, and I think it was the Azure guys who said it's code and events. Well, I'd define it as compute and patterns, which is very, very similar. So I think the term serverless can be attributed to the growing popularity of function as a service technologies, which are often described by the vendors as serverless. But I think if you look at the way people are actually using and building serverless systems, there's a lot more to it than just compute. So my view is that serverless is a theme. It's an approach to building applications, and it's comprised of compute and patterns. So there are serverless compute technologies like these and a few others. And there are serverless architectural patterns. So these are patterns for crafting systems without traditional back-end servers. And generally that includes integration with third-party services, whether they be native cloud services or other web services. And the real power of going serverless comes from integration with other services. hooking functions into services to orchestrate rich and powerful event-driven pipelines. And this was referred to by Patrick Dubois, founder of DevOps Days, as a service-full approach. And I really like that. It's where cloud services are heavily leveraged, you're service-full, and serverless compute technologies are used as like the last mile to weave these things together, weave these custom components and third-party services together to solve some unique business problem. Okay, so there we were. It was mid-May 2015. We wanted to launch our startup. We wanted to rocket to market. You're gonna have to go. I've got a metaphor here. You have to go with me on this. So we were stuck firmly on Earth. We had to find a way to escape the gravitational pull of our normal lives, our mortgages, our financial commitments. So we needed to get something to market and see if we had a product that people actually wanted to use. So we needed to achieve escape velocity. We needed to get away from that gravitational pull keeping us on the ground. And we had to start earning enough income to keep ourselves going. But we were trying to work out, how do we get going? How can we build this thing? So I'd love to stand here on stage and tell you that we had this grand vision to go serverless, an epiphany, like an apple fell on our head, and it was like, serverless architectures. But it wasn't, and I think like so much innovation, it started with a constraint. So I could only afford to spend 4 weeks building the school, first version of the school. I've got a wife and 4 kids, so with our 4 kids, we flew down to live with the in-laws for 4 weeks, and I locked myself in a bedroom for 4 weeks, and the family were looked after, and I built a learning management system. So to be successful, it had to have video lessons, a quiz engine, an online store, sign up, log in. It had to scale effortlessly because we knew we were hoping to get a lot of students very quickly, and it had to not need a lot of operational support to run. So kind of daunted by the scale of trying to do this from scratch, I decided to try off the shelf first. So I spent 2 days of my life trying to configure Moodle and skin Moodle, and it was just horrendous. And I wanted to give up, and I started freaking out, like, what have I done? Maybe I should just have a holiday. And then I started thinking, well, how could I outsource as much of this as possible? Like, what's already a solved problem out there? And what accelerators are available to me? And then I remember playing with Auth0, which is authentication as a service. Awesome product. And in previous projects, I'd spent weeks alone implementing authentication, creating a sign-up screen, a login screen, forgotten password wizards, social media sign-in. It's a big problem to solve. And with Auth0, you can just create an account, drop a few lines of JavaScript code into your website, and it's all done for you. Even the login box is made by Auth0. And we still use that to this day. And I also remembered playing with a service called Firebase, who are sponsors of the conference as well. So, woo, go Firebase. And Firebase was a NoSQL database, but it was done differently. It was built for the web. So Firebase's database can connect directly into the web browser, meaning that when your site loads in the web browser, it can talk straight to the database via the web without you having to have any intermediate web servers in the middle. So now I was able to put a whole bunch of course information into Firebase, like titles, descriptions, lessons, quiz data, and have our site access it directly from the user's browser with our front-end AngularJS code. And I didn't need to have a middle tier layer to act as the proxy between the front end and the database. And this saved a huge amount of time early on. It was less time spent on plumbing and infrastructure, that undifferentiated heavy lifting. More time spent building useful features for our customers. But there's some things you can't do in the front end. Actions that load like private, sensitive data, calls to additional services, like if you're authorizing credit card payments, there has to be some workload, some parts of that interaction have to be done with secret keys behind the scenes. So this meant that I needed a web server, which I found really frustrating because I only need to do now a small handful of things in secret, in the cloud. But now I had to think about scaling and infrastructure and monitoring. And then I remembered WebTask. So WebTask was a service that you could upload a single JavaScript function to, and it would expose that function at a HTTP endpoint. You could make a call to invoke that function. It would return the response. It was originally built as a way to do small webhooks without having to stand up a whole web server. So I realized that for the few protected actions we actually had to do, like authorizing payments, we could do them with WebTask. So I would write a small amount of JavaScript code. I would upload it to WebTask. It would give me a HTTP address back. I would put that into our front-end app. It would call that address. WebTask would run the function on demand, worry about scaling it all up, run it in a protected environment, and now it would call out to Stripe to finalize the payment. And then once it was finalized, it would write the record of that payment into Firebase, and Firebase via WebSockets would sync that all the way back to the browser, all completely push-based and event-driven from browser to browser the whole way around. And then after some time, API Gateway came out in Amazon, and we were finally able to invoke Lambda with HTTP, and then we moved over to Lambda to run those functions. So with a model like this, we had a truly standalone front-end app. If you think about it, the HTML, the JavaScript, the CSS didn't need to be served by a web server at all. So that we could literally plonk it on a CDN, and it meant the assets could load lightning fast, really quick, be distributed globally. So really what we had was a first rudimentary, entirely serverless architecture. And the whole thing was served by web services that other people had to manage the provisioning of and the scaling for. And best of all for us, being a startup, it was very low cost. Like the bills scaled exactly, very tightly with usage. So as demand increased, we paid a little bit more. So this architecture is really good for the request response scenarios of the web, but user does something on the site and it's a short action. But how do you kick off longer running processes? Something that could take minutes or hours, and what if it has multiple stages? Well, then we worked out that we could use serverless architectures to build event-driven pipelines. It's really well suited to that. So you can build these robust event-driven pipelines. So we built an entirely serverless video transcoding pipeline on AWS. So it went like this. And this is still how it works today. So Peter comes in, he's an instructor on our site, gets in the web browser, and he wants to upload a new lesson. He's made a new lesson on teaching something in cloud. So he uploads it. He uploads it straight from the browser to an S3 bucket, where there's no middle layer in the middle from us. Our S3 bucket is configured to kick off a Lambda function when a new file arrives. So we kick off a Lambda function, and that Lambda function creates an Elastic Transcoder job. AWS Elastic Transcoder is a service that transcodes videos from an input source to multiple versions, like a 1080p, a 720p, 480, WebM, HLS, all the formats we need to deliver to different clients. And it dumps them all in another S3 bucket. That's the destination bucket. Now we hang another Lambda function off that S3 bucket, which looks and says, oh, great, so this is invoked every time a newly transcoded video arrives. Oh, great, there's a 1080p version now. Awesome. Let's write that record to Firebase. Firebase syncs it back to Peter in the browser, and in his nice little instructor interface, he says, oh, great, 1080p version available, 720p. It's all nice and transcoded. Now I can publish it, make it live for students. So that was cool. So we launched the site at the start of 2015, September 2015, I should say. So about 19 months ago. And look at that, we had Liftoff. Woo, animations. These animations are going to blow your mind. Prepare. And the business took off, and it started gaining customers really fast, like faster than we thought. And it was kind of like, whoo, thank God for serverless. And people really enjoying the content, and our website was delivering on its core functionality, and we didn't have to worry about infrastructure, which is great. And a monitoring team. We didn't have to worry about a monitoring team. We could just monitor ourselves with alarms and things in CloudWatch. So there we were, speeding across the solar system in our serverless rocket, and we'd escaped the gravity of the real world. And just like a rocket, serverless gave us a whole bunch of accelerators to move faster. But then we started realizing that things were a little different up here. There were basic things that we took for granted back on Earth that just didn't hold true in this new model. So like, gravity and oxygen are missing in space. Some simple things are hard, or were hard, in the serverless world. And we had challenges with things that we used to take for granted, like debugging, offline development, local development, even crawlers being able to crawl our site, tools for organizing and orchestrating and deploying serverless systems. A lot of this just wasn't there. So I'm going to take you through a few of those and how we solve them, because a lot of these still hold true today. So crawlers, people were taking our courses and they started sharing them on Facebook and Twitter and Slack and sharing URLs. And then this happened. That's what it'll look like when someone shared our site on Facebook or shared a course. Hey, go check out this awesome A Cloud Guru course. It's post.title. Awesome. And the problem is that our site was just hosted on a CDN. It's just raw HTML hosted on a CDN without any of our web servers in the middle to render that HTML out with some pre-populated content. So the app is loaded in the browser, it bootstraps itself, and then it goes off and fetches content and shows it on the screen. Now Google, when Google crawls a site, it'll run the JavaScript. It'll wait for the JavaScript to load and run, and then it will scrape the HTML. But Facebook, Slack, Twitter, they don't do this. They just get the raw HTML. So when Facebook asks for the HTML, it just gets back just that, right? Whew. So this is actually, I know this is like, you could say this is a common problem in the world of single-page apps, and it is, but when you're serverless, you don't have a web server to sit in the middle and inject some content in there. So we solved this by moving over, oh, yeah, that's right, I've gone too far, to a static site service called Netlify. So Netlify hosts all of the static HTML, JavaScript, and CSS and distributes that globally. It's backed by a CDN, as any good CDN would. It distributes it globally, but it can also detect crawlers, and it can reroute requests to serve up different pre-rendered HTML content to a crawler. So here's an example. So a normal user opens their browser and requests a Cloud Guru. Just in a normal web browser, Netlify hosts that content, receives a request, responds with the standard content-free HTML. The app loads, all is good. But if a crawler like Facebook, Slack, or Twitter make a request, then they send a very special query string, escaped fragment. And that identifies that they're happy to accept a pre-rendered version of the page. So Netlify actually detects that, and instead of serving the normal HTML, it makes a request out to another service called pre-render.io. Netlify does have its own pre-renderer, but pre-render.io has a lot more features. So pre-render.io basically opens websites on demand and renders the pages. It allows all the JavaScript to run, and then and all the content to load, and then it gets that HTML. So once it's loaded, it takes a snapshot, and it caches that HTML as well. So you can set timeouts. You can say, I want to recache every page every 5 days or every day. You can recache it on demand. So if we make a change to some content in our site, our Lambda functions that make that change can then go off and tell pre-render.io, just pre-render the page again. It's changed. So when it's requested, that's what gets returned all the way back. And then we get these beautiful previews. That's a preview from Slack. And that's a URL that if you actually hit that URL, there's no content in that HTML. So that's been filtered by Netlify and pre-rendered. So that's a nice, and it's actually quite a simple, elegant solution. It's not a very expensive solution either. So on orchestration, I mean, when we started, we had to orchestrate a dozen or two Lambda functions and API gateway endpoints. And that was hard because there was no serverless framework and there was no serverless application model. So we literally wrote build scripts in Grunt to package up Lambda functions and bash scripts and deploy them to AWS with the CLI. And those build scripts even supported multiple environments. It was awesome. It would like append the name prod to the end of your Lambda function. So cool, super advanced. And there was no, I think probably the thing we found hardest is there was no like central manifest of the system. You couldn't just look at a file and say, well, here's all our functions, here's the API endpoints, and there was no way to deploy it atomically, like with CloudFormation in our service. So it was a massive time suck, and sometimes, honestly, it felt like we just swapped one set of problems, managing and monitoring infrastructure, for another, which was orchestrating the deployments of dozens of serverless functions. And so obviously, thankfully, the ecosystem matured and the tooling improved, and thankfully Austin Collins came along and presented JAWS at reInvent and built the serverless framework. So that's what we use now. I'm sure a lot of you have used it, but it really for us, I wanted to summarize the value for us. It's one central definition of our serverless system, inbuilt support for managing multiple environments, robust deployments with CloudFormation, with rollback if something goes wrong, great plugin support, a great community. Some of our developers contribute to the framework ourselves, and it really simplifies event wiring. So if you're going to wire into SNS or S3, you can wire that. You can do that all in that kind of central manifest, that one YAML file. So debugging, this was also a major pain. We didn't have a lot of unit tests early on. It was just about getting to market and seeing if anyone wanted to use this thing. So a lot of our testing was manual to start with on local dev environments, but you couldn't run Lambda locally. And then you'd get into the cycle of despair. You would write your code locally, you'd save it, then you'd upload it to AWS, and anyone who was in our workshop yesterday knows this pain. And it takes a minute or two, especially from Australia. We don't have the internets that you guys have here. It takes time. And then you'd run it locally in the web browser, and the website would call out to AWS, and then it would fail, and something would go wrong, and then you'd open CloudWatch in the browser, and you'd troll through endless logs, and you'd hate life, and you'd find the issue, and you'd go back to the start again, and change the code, and go around and around. So that was development, and it felt like we'd gone back 20 years. And then this plugin, Serverless Offline, a plugin came for the Serverless framework, which lets you run. It basically simulates API Gateway and Lambda locally on your dev machine. So you can work on the front end of your website, and you can host that locally in a local web server, as you normally do, like in web development. But then you can have your local copy invoke Lambda functions by calling a simulated API Gateway locally on your computer. And then this executes that relevant Lambda function. It's all done in proc, just in Node. And it's really good if you just want to test the integration between your front-end code and the back end. If you just want like a fully functioning environment operating locally. So it's fine for simple cases. It's really good for just simple invoke a function from the web. But beware, there's a lot of things it doesn't do. It doesn't simulate any other AWS services. So if your function is running locally and then it posts a message to SNS, and you have a Lambda hanging off that SNS, you end up with like a Frankenstein monster. Like you're debugging something locally, and then suddenly you're in the cloud. And Lambda functions are being invoked in the cloud. So you have to be very careful with what you do. Serverless Offline is not a proper emulation. It's not a fully sandboxed container like Lambda is. It's not going to emulate the compute and memory configuration of your Lambda function either. So there are some significant limitations that you just have to understand going in. But for simple cases, it's really good. I really recommend it if you're getting started with building a serverless web platform. There is another project which this is pretty cool. It's called Serverless Simulate. And this is an open source project that some of our developers are working on. So people like John McKim and Dan Parker, who are here today, and another guy in Brisbane called Gert. I can't pronounce his last name, I'm sorry, but he's a cool guy. They're all working on it together. This isn't completely finished. We want your help, but it does work. It aims to simulate Lambda and API Gateway more closely, to more closely emulate some of those pieces. So it'll simulate API Gateway locally, but it'll spin up a local Docker container to execute the Lambda function. It's actually using the Docker Lambda open source project. So it respects Lambda timeouts and memory configuration. And one of the reasons we started this is because it supports Lambda chaining. So you can have one Lambda function invoke another Lambda function, and that will still get executed. It'll spin up another container locally and execute that. So we do a lot of that we use a lot of GraphQL endpoints these days, and we have Lambdas call other Lambdas. So it's really useful. But beyond a magic tool, like what's really going to make all of these problems go away? Because you can't simulate all of Amazon. Well, just test everything. It's really the best advice I can give you. If you cover your Lambda functions with a robust suite of unit tests and integration tests, and you kind of validate the combination of expected inputs and expected outputs, then there's less need to debug and emulate Lambda locally. Instead, as you're writing your functions, your Lambda functions, you're executing them with your testing framework all the time. And that's been the real solution to our problem, if I'm honest, introducing that suite of unit and integration tests to all of our Lambda functions and getting really great coverage across the board. So if you think about our architecture, yeah, we were serverless and we were built on Lambda and it was cool, but it was a monolith. We'd effectively built a serverless monolith. One database, everything coupled to it. And that's okay, like, it's not a dirty word. It's okay to build monoliths. I think it's actually a good place to start when you start a business, you start a product. It got us to market, it created the business, but as we scaled, it presented challenges. So we had the front end coupled directly to the database in Firebase. So how do you add mobile apps? You don't have a versioned, consistent API in the middle. And Firebase exists outside of AWS and CloudFormation, so provisioning new environments programmatically was hard. And how do we scale from this monolith to have, from just a few developers to 5, to 10, to 20, to 50 developers, without everyone stepping on each other? And that's the problem that we've been looking at over the last 6 months, really, in the business. How do we scale this? So, animations. So we decided to go to microservices, a microservices architecture. And this is where each business domain is represented by a separate microservice. And each microservice is responsible for its own view of the world. So its own database, its own API. And this allows us to achieve acceleration with highly focused teams who own and are accountable for one area of the system. They know it inside out. They can iterate quickly. And it also allows services with different scaling characteristics to be scaled differently. So we can allocate different read and write throughput to DynamoDB for different services. Login has very, very different demand characteristics than just updating a course, which is done not very often. So, relatively. So this is an example of how our microservices work. So this is the learning record service. So this service is responsible for keeping track of user participation in a course. Someone goes through one of our online courses, this is how we keep track. So, for example, like someone completes a course. The request comes in from the browser, straight to our API gateway. We actually use GraphQL now, but for simplicity, I won't go into it. A custom authorizer runs from API gateway to make sure this user is who they say they are, and they're allowed to access these Lambda functions. It then calls a Lambda function, which is responsible for looking and validating and saying, well, does this user actually have access to this course? Is this user really completing this course? Does it make sense? Great. Save it through to DynamoDB. So DynamoDB has become our source of truth. Firebase for us now is a view that the user interface reads from. DynamoDB is a source of truth, so we update the source of truth. But then we took inspiration from, I think it was Paul Johnston in the UK at one of the last serverless conferences said, a Lambda function should have 0 or 1. It should do 0 or 1 data transformations and no more, because then it has one responsibility, it can be well tested, and I really like that model. So we do 1 data transformation. We save the record to Firebase, to DynamoDB. But then we hang streams. We use DynamoDB streams and we hang Lambda functions off Dynamo. So when things change in that source of truth and we know something is now persisted and recorded, we can then take other actions in the system and we can update other views, other pieces of data in the system. So for example, a lot of our user interface is still coupled to Firebase, and to move away from it is a lot of work. So instead of trying to completely re-architect the system, we've just moved the source of truth to Dynamo. And then every time something changes in Dynamo, we update Firebase. So Firebase becomes a read-only store. And that's actually a really nice experience in developing a user interface against Firebase, because they have great developer tooling. And as something changes in Firebase, it goes straight out to all of the users via WebSockets who are connected. So we don't have to continually poll for changes through an API. So that's really nice, but if we have a mobile app, it doesn't have to be connected to Firebase or coupled to Firebase. It can use an API or a GraphQL endpoints to query what's in Dynamo. We also use Algolia as a search service. So for full text search, really, Algolia is awesome. If you're building serverless apps, have a look. It's completely distributed, globally distributed search. So you have a search index, they replicate your search index around the world, and you can choose where you want it replicated to, and you can look at the latency response times to each area of the world. So you can kind of see what we've done there. And if you think about what we've done, and this is, I think, to me, the power of serverless. We've migrated, in a period of probably 6 to 9 months, from a completely monolithic architecture to microservices without ever having to think about infrastructure. We've completely changed our architecture We haven't had to think about server provisioning, web farms, load balancers. We've changed it simply by changing a single YAML file in serverless framework that defines our system. And we hit deploy. And suddenly everything's different. CloudFormation seamlessly upgrades that system for us and keeps it running. And last of all, I think I would caution anyone going into the serverless world that managed services are moving targets. You know, this is a difference, right? You're building now against managed services, and managed services change all the time. So we got hit by, like, Lambda are dropping support for Node 0.1, I think in a couple of days. So we've spent a few weeks, we've been forced to upgrade some of the really old functions we had from early in the system that were still there and running, and they were fine, they were operating absolutely correctly. We've had to move and upgrade them. And you can't just upgrade something without fully testing it. You can't just switch it to Node 4.3 and just hope for the best. Well, you shouldn't, don't do that, don't do that. Firebase came out with a new version and made their old version obsolete, and so we had to fully test that. So these things move, and so you have to understand the world you're going into, and it's okay. I think the acceleration, absolutely the acceleration we've got has justified having to sometimes change things on other people's schedules, but it is something you have to be aware of. So briefly before I wrap up, this is where I get to do a plug. We ran the workshops at the start of the conference, the pre-conference workshops yesterday. We have 4 workshops. We do these for companies. We go around the world. Our guru team go around the world and go out to different companies and show them, run these in-person workshops and get hands-on. Show people how to build their first serverless system. So if you're going away from this conference and thinking, hey, I really want to bring this back into my company, I want to show people how to do it, that's a great way of introducing people. They get to build their first serverless apps. So you can hit that website if you're interested, acloudgurus/serverless. So that's it. I mean, we went from nothing to a serverless monolith to serverless microservices, and we solved the problems of crawlers, local debugging, orchestration, and deployments along the way. And I think all in all, building an entirely serverless app has had a lot of advantages for us, and it's been a lot of fun, not least the cost advantages for a startup. It's presented some interesting engineering challenges that we've had to solve, but I really firmly believe it's enabled us to move at a pace that we couldn't have otherwise, and actually we wouldn't have a business because there's no way we could have built the initial system any other way in the time that we had. So that's the story, and thanks for listening.